So today the ds-incubator continues on the series about using Docker images, and I remind you all that this is very focused on the usage of the images, and we'll cover next the maintenance of the images, how to remove images, how to remove containers, how to stop them, how to start them, things like that. But the original goal of this meetup, this series, is not to become an author of Docker images. It's more about using the images that other people create for us. And the reason why that's the case is because there are already a bunch of images out there that are pretty useful for a bunch of use cases. And today I wanted to demonstrate a little bit of that. So basically, when I advertised this series that was eventually selected by you all through voting, I described a few use cases that motivate this meetup, and I wanted to touch on a couple of those. Particularly, I'm interested in showing how to get a bash terminal, a simple terminal on your computer. And that may not be super exciting if you're running a Mac or a Linux system, but if you're running Windows, it is important because another topic that got highly voted was the basics of the Unix terminal. So if you're running Windows, a future ds-incubator about the terminal, it could be very useful if you are able to spin a Docker container running Linux, right, and giving you access to a bash terminal. So it is very intentional. So the use case, the first use case that I'm going to show now is precisely targeting that. I'm going to show you how, if eventually we get to a series about the terminal, then how you could use Docker to give you a Unix terminal, even if you're running on Windows. And I can talk about more about what it means to be a Unix terminal as opposed to a Windows terminal in that series in particular. But for now, all you need to know is how you actually can access such a thing, a Unix terminal. So all the meetup is going to be based on a specific image that comes from the Rocker project. We mentioned that before. The Rocker project builds a bunch of images, and they are built in layers. And we're going to be using one that is quite complete. Maybe not ideal for all the cases, but it's going to be useful many times. So I'm going to show how to use that particular Rocker image for a couple of different things that cover a lot of our day-to-day challenges, I would say, that could be solved with Docker. So I'm going to be using the terminal. Let's see if I can bring my terminal here. And I'm going to be walking through this command. I apologize that the materials for today are going to be a little late. Usually by the time the meetup starts, I share them. Today, I had some issues with Docker Compose. That's why I'm not going to be showing Docker Compose much now. Something that I need to debug with Alex, probably. But I will be basically explaining what this command does that you can use for specific, I had to tweak it for specific use cases. And later, I'm going to be sharing this in a file on the repo so that it's kind of more explained, right? Okay, so remember that we covered two ways to do the same thing with Docker. One was using the vanilla command Docker, and the other one was using Docker Compose, which was basically a simpler interface to run a bunch of commands like the ones that you see here. So for those who are not used to the terminal, this all this text on the console here surely looks intimidating, but today the goal is to revisit this command that in a simpler form we saw before, explain what each of these things are doing so that you can understand how to tweak it if you want to apply this image to a different use case. So what you see right now, for example, is going to be giving you a bash terminal. Bash is just the name of one kind of terminal. That is the one that we could use, for example, if we did run a series about using the bash terminal, right? About just getting more familiar with the terminal. So for now, all I'm going to do is run it and then stop that container. I want to first to show you what this will produce, and then we're going to break it down. So if you don't have to kind of take notes or anything, because I'm going to be sharing this command in a README file anyway. So if you run this command, what you get is this thing. It's a terminal, something that also has, as you can see, ends in home. And the reason is because this command has some tricks so that you can access from inside the Docker container all the files that you have in your home directory. So if I do an ls here, which lists the files that I have in the current directory, I can see that I have here access to the exact same files that I have in my actual computer, but this is not my computer. This is, a container. So, but I still can modify and create files from this container. So let me stop this container and go back to my system. So what I'm going to do is run exit, and that takes me back to where I was. So let me now clear the console with Control L and do an up arrow to record the command that I showed you before. And now let me break it down a little bit, and then I'm gonna give some time to ask questions. So today I'm gonna be working all the time with this image that is called Rocker Verse. And in particular, I'm describing with this column here, I'm describing which version of R I want to be installed in that particular image. So Rocker Verse can be used with a bunch of, pretty much with any version of R that is available out there, and with just by saying 4.1.1, I'm saying that I want that image to have that particular version of R. The other thing that I'm doing here is, remember I told you that I have from inside the container access to all the files in my computer. The trick is done in these commands here. What I'm saying is, okay, my computer knows what is the path to my home directory. So where I have a lot of configuration files and all of the files that I use in my computer, and the way to access that path in a way that is not explicit could be with this variable called home. We touched a little bit on the meaning of variables last time. Pretty much it's just one name that contains information. So it's a key value pair. In this case, the key is home, and the value is whatever is the actual path, the literal path to my home directory. So I don't need to type it, and the reason why I choose to use this variable as opposed to hard coding it is because I would like to share this command with you, and I would like you to be able to run it verbatim and so that it works, right? So if I hard coded my path there, if you run that command, it won't work because it would be looking for something that says Mauro in the path. So this is what does the trick of allowing me to access all the files that exist in my computer, but from inside the Docker container. Then I'm giving this other parameter here called workdir, which I'm saying to this container that once the container starts, I want it to start from a particular directory. So what I'm doing is jumping inside that home directory so that the experience feels very similar to what it is when I use my own computer. What would be alternatives? Well, an alternative would be to be dropped somewhere else, anywhere in the system. Usually you start at what's called the root, which is the highest level or the lowest level. What would that be? So it would be the slash directory in a bash system. I'm going to show you that in a moment. And finally, what is most important actually for this command is that the very last thing that you type here is what is called an entry point, how you enter the container. So in this case, I'm typing bash, which is the name of a program. So by typing the name of the program, I'm telling the container to start particularly with that program, right? So let's do that once again. So by saying bash, I'm saying use this image, give me access to all my all the directories in my home directory, and start with bash. So this is what it is. As you can see, again, now that you know what it means to be in a home directory and what it means to be somewhere else, let me do a cd ... which takes me back to the root. So if I do an ls now, you can see that in the prompt, there is a slash here. There is not a slash home because I'm as low as I can go in the structure of my of the file system of this container. So if I wanted to go back to my home directory, what I would need to do is cd home, and now it takes me there, where if I do ls to list the files, I could see again the files that are familiar to my own system. So before I exited the image with the word exit, typing it literally, but you can also do usually a Control D. A Control D would type exit. And I'm back to where I was before. So now I'm gonna show you how to tweak this command to, instead of running the terminal, to run, for example, R. And which version of R we are gonna get? Well, we're gonna get the version 4.1 because that's the one that is installed in this system. So let me remove the word bash and let me type just R. That's how you execute R. And let's run that. So as you can see, I'm already inside the container, and it's running R 4.1.1. So I can now exit here with quit. So to quit R, you don't do exit. It doesn't work. What you need to do is q parent. So if I wanted to run another version of R, say 3 or 4.0, this is how I would tweak the command, 4.0, right? And then again, I run that with enter. And what's happening now is that Docker noticed that I don't have already in my system the image Rockerverse 4.0. So what it's doing is going to a website called Docker Hub, and it's finding it there, and then it's pulling it from there and is storing it in my system. The reason why it didn't happen before is because I had run that command earlier before I started the meetup, so the image was already in my system. So the way Docker works is when you ask it to do something, it's going to try to be as lazy as possible. If it detects, for example, that something that you are asking for is already somewhere where it can get it quickly, for example, because it's already installed in my system, it's gonna reuse it from there. It's this idea of cache. So a lot of the things are already stored somewhere where Docker knows about, and if it can reuse it in a way that will save you time, then it will do it that way. And if it doesn't, then it goes first to, in this case, the default, what's called repository, is Docker Hub, which is similar, in the same way that GitHub is a repository for Git repositories. In this case, Docker Hub is a repository for Docker images, and we're probably going to be covering how to how to find images in Docker Hub in another meetup if there is interest. But for now, all I wanted to show is this one command, this one image, and how you can tweak that command to suit different use cases. So just to review, while this continues to download, the different use cases that we explored were how to use that image to get a bash terminal. For example, for the meetup that we're going to have eventually, hopefully, about the terminal. If you want to play, for example, with a Unix terminal before, say, you switch from Windows to Mac or to Linux, for example, if that's something that you're contemplating, you could experience what it feels like to use a Linux terminal that way. So that was one use case that we showed. Another use case that I showed is to how to run R directly with any version, and in which cases the different versions could be useful. Well, for example, if you are running a relatively old version of R and you want to see what the new version of R feels like, then you can install that newer version, the latest version, in a Docker container and not affect your local system. Or the other way around, say that you do have the release version of R and you want to, say, reproduce a problem that someone has experienced with an older version of R, then you can leave your system as it is and then use, for example, this image to get and modify the column, in this case 4.0 component, right? The tag was called the tag component. Modify it to get the exact version of R that you need to reproduce the problem that someone has reported. So this is a little bit a wrapper of how to do things that are common in the day-to-day life of an analyst, of a developer at 2degrees. So with this, and while this completes, I'm gonna open the floor for questions. And I apologize for not showing Docker Compose, how you would do the same with Docker Compose, which is fairly simple. Just do Docker -compose up, and that will do the trick. But I'm not doing it now because I'm not sure if I recorded that in the meetup, but the issue is that I'm experiencing some issues with the installation of Docker Compose. So unfortunately for this meetup, I cannot show it. So go ahead and shoot some questions. We have 10 minutes for that.
So I had a question about the command that you're using, the Docker command. And does that actually work on Windows with this? Is that how, does this home environment and variable work the same way on Windows as it does on Linux?
That's a great question. Before using Linux, I used Windows. That was maybe I switched a year ago. And I do remember having a really bad experience trying to copy paste the code that I got from tutorials online. And I think it all worked. I mean, eventually got everything working, but it's true that sometimes the exact way in which the variables are typed don't work in Windows, and I had to surround them by quotes. So to be honest, this particular command that I typed there, I didn't think of Windows compatibility, but maybe someone here in the room, maybe Alex or other people remember if that syntax is valid for Windows?
And one quick
yeah, go ahead, CJ. I think you know.
Well, one quick suggestion was that, I know Windows users can also download a Git shell.
Mm-hmm.
It comes with Git, I think, or it's, I don't know. They make a command shell that looks like your window, like a normal Windows command prompt, but it actually has all the same commands as Linux. So this is one way to use
to bypass that problem. Yeah. Yeah. That's so cool. So that's a very good trick. So use a specific shell that knows about the Linux type of syntax. Again, I know that with the shells that come, like the PowerShell, for example, that comes with Windows with a particular syntax, I think surrounded this by quotes, it should work. But if you are experiencing that problem, I'd be really interested if we could sit down in a meeting, maybe in a help desk or something, so that I learn what differences there are. Alex or someone else would like to make a comment about difference in syntax for Windows?
Just to say that home is not a built-in environment in Windows, but adding a new global and variable environment in Windows is fairly straightforward once you know how to do it. And you can define your own home environment to your user directory or something.
Perfect.
I do have some other thoughts from the discussion, unless someone else wants to jump in.
Let's give a few seconds. Anyone would like to shoot some question before Alex or I or someone extends with comments and suggestions? Okay, go ahead, Alex.
One being the idea of using git bash for Docker commands, and that is technically possible, but overall git bash is limited in what it can do. They haven't ported the full suite of Unix utilities over to Windows, so that can be prone to errors. If possible, and if you're comfortable with it, pretty much every version of Windows comes with the option to install the Windows subsystem for Linux, which basically installs a whole Linux machine as part of your Windows installation, and it just sort of transparently navigates everything for you. And that is it is a pain to set up, but once it's set up, it works great. And then the other big thought that I had is on use cases for something like this. Like, in addition to what Mauro has said around wanting to try a different version of R or wanting to play with a different version of Linux before you commit to installing it, I find a really common use case for this is if there is some piece of software that is finicky to set up or is going to have a lot of side effects and be difficult to uninstall. So whenever I'm working with databases, I never install Postgres on my local machine. Instead, I always run it from a Docker container because Postgres is kind of a pain to deal with. There's other pieces of software that you will come across that are similarly like, if you can run it inside a Docker container and avoid having long-lasting effects onto your system where it's never quite scrubbed away, Docker container is the way to go for that. But I guess one of the biggest use cases I have for it is, Mauro, if you can jump back to the terminal with the command. So in the volume specification, the -v home to home, if you add another colon and then RO to the end of that, that mounts that directory as read only. And the value of that means that now, yeah, just like that, this is now a one-way mounting. Everything that is on my local computer, my actual physical computer, is available inside the Docker container, but I can basically run around with a sledgehammer inside the Docker container and not worry about breaking the things that are on my actual computer. So it's very nice to have that check valve of I can make changes, I can do what I need to, and test it out without worrying about breaking something that I continue to have to use every day.
Okay, that inspired two extensions of what I showed that I would like to mention if there is time, but I'm more interested in questions because this is pretty much all you need to know to use images that someone else created for you. So if you're not so much interested in like the details about how to manage, the images once you have them in your computer, or if you're not super excited about the technical details, then probably the next meetups are gonna be an overkill for you, and this could be a good stopping point. So it's a good opportunity to ask questions because Docker, particularly Docker Compose, can be a bit too magic. Because it just happens, you just type Docker Compose up, and everything that exists described in a particular configuration file that I would like to revisit in a moment will just create the container that you want. So pretty much, if you're wondering, okay, I don't understand this thing, it's very likely because we haven't explained a lot of what this thing, each of these things are doing. But it's intentional. It's like, you are now empowered to just, run a command that say, hey, run this, and it should work, and it should work. That's the magic of Docker that saves a lot of installation time. Just by running one single command, you can do an infinite number of things that are described in a configuration file that someone else describes. So as long as you have the folder that contains that particular configuration file that's what you want, then all you need to know is just to run that one command, Docker Compose up. So I would like to show what the two things I would like to show now is, the most important one is what that configuration file looks like. So Alex, I'm thinking of maybe showing some, because I typed a couple of Docker Compose files, but I'm not confident in my own skills of creating Docker Compose files. So while I speak for another few seconds, I was wondering if you could think of a repo where I could go and show what it looks like, so that it becomes a little less magic and people know where things are coming from. Go to
the 2DI data store.
Perfect. Okay, so
It's been a minute since I've looked through that one, but it's got some good stuff in it.
okay, let me see. I'm gonna go from here then, because I need access data store. Okay. So where am I trying to get in relationship to the use cases? So in the description of the things that you could do after this meetup, one thing that I said is that you can share your entire computer environment with someone else. What did I mean by that? What I mean is that if someone like Alex, for example, wants to give me a computer environment, you know, a particular operative system, a particular version of R or whatever, all he needs to do is to create a GitHub repository with a specific configuration file that is called docker-compose.yaml, and then tell me where it is. And I just clone that repository, change directory inside that particular directory in my computer, and then run Docker Compose app. So Docker Compose app is aware of where it is being run from. So what all you need to do to share a computer environment is to share a URL, a link to a GitHub repository. That person clones that repository, navigates to the directory that contains that configuration file, and runs Docker Compose app. So that's all that there is to sharing a very complex system that would otherwise take hours, if not days, to install. So in this repo, Alex, which folder do you think would be an example for just to show, you know, what that folder would look like?
So if you just scroll down to Docker Compose a little more.
Perfect. Good.
And the one at the bottom there looks good.
Perfect.
So this is the default Docker Compose script. And we can see here that this is actually doing some fairly complex heavy lifting. So line 2, real quick, is services. That's just part of the Docker Compose specification. And then the next indent in, so lines 3, 12, and 23, those are defining the different services that are being spun up as part of this. So we actually are getting 3, I think if we scroll down, there's maybe 4 or 5 different containers are actually going to be activated when you run Docker Compose up. And what that lets you do is if you have multiple related pieces of code that need to interact with each other, this is a very powerful way to just turn them all on at once. And you can maintain each of them independently and keep them isolated for development and testing. But then when it comes to actually use them, you can use them all in conjunction with each other.
Good. So just to revisit what it could mean to share a computer environment, basically, you know, you go to the repo, you copy the URL that allows you to clone a repo, and you could clone it as you could normally do. Git clone, and you paste that URL that you copied, and that will, you know, get you that content. And then once you have it in your computer, you do a cd to get inside that repo and run Docker Compose app, which I won't run, unfortunately, because as I said, you know, my Docker Compose is messed up. But that's all that there is. So, like, truly, just if you know how to clone a repository and how to type, you know, Docker Compose app, if the person who developed that configuration file did a good job, it should just work. And of course, you need Docker and Docker Compose installed in your system. So all you need to do on your end is to install Docker, install Compose, and then you're good to go. Maybe we have, well, actually we are beyond the time, but if anyone has a question, please shoot it anyway, because it might be the last time we see you in this series.
And I think that Data Herald might be canceled. So if we go over, it's not the end of the world.
Yeah, it seems like it. No one's responded to say that they have points, so I believe it's probably canceled.
Okay, good.
So what's the reasoning behind putting the Docker Compose file in a Git repo? But because you can just pass, like you could email the Docker Compose file to someone also, right?
So if I can jump in here.
Yes, please go ahead.
So Mauro, can you jump back to the data store repo and go into the Docker Compose file? So this is where we're getting to the point of um, what are the next logical steps with Docker? What are the things that we haven't covered here? But if we look at lines 13 and 14 here, we've got, so as a comparison, we have line 4 is image Microsoft Azure CLI, right? That's very similar to in last week's Docker Compose, we had image Rocker RStudio. It's just saying, go grab this image out of Docker Hub, throw it up, and start running it. But if we look at lines 13 and 14, that is build context. That is saying we have our own Docker image that we want to build. It is not something that is already on Docker Hub. We want to build this fresh every time. And so what that lets us do is if we have a Docker file in our repository, that lets us define more specifically what the computing environment is, right? So, for example, Rocker RStudio is a great image out of the box, but it doesn't have Postgres drivers if I need to connect to a database, right? Which has been an issue for us back when we were running our data store ourselves. So with this, we can create our own image starting from something else, from like Rocker RStudio, add in all of the other software, install all the packages that we need, and then that image is ours, right? And so the reason to have the Docker Compose as part of the repository is if you are adding code into a Docker image, then you can also keep the command to run everything all together next to the code as well. And if you make changes to that code and run it again, then those changes to the code will also get picked up and included in your next run.
So it's relevant if there are other files that you also want to include next to it so that the Docker Compose can find these other files in the same place. Yeah.
Is there any other question or comment? Okay, what I have as a plan, and maybe while you think your last question, what you have as a plan for the next meetups of this series. So first, I want to make this series short. Sorry, go ahead.
Just thought of a comment, but maybe I think my internet is also a little bit choppy. So I think it jumped in a little bit late.
Yeah, go.
Just another for maybe like, I guess I don't know if there's people here who still want the more practical use cases of Docker, but Alex was saying for like a finicky software or something like that, or maybe it was Mara for setting up finicky software. But like honestly, for just about any open source project, like if we find interesting like sustainable technology projects or whatever PCAF releases like a new model that you can that we want to compare against Pacta or something like that. Very often there will be a Docker file that you can just kind of spin up and click go, and it's the easiest way to get started with it. I don't know if that was mentioned already, but.
Thanks. Yeah, it's such a high-level abstraction. It's kind of cool. It's a single interface to run an infinite number of things. So whatever happens is an implementation detail, if you will, that might be described in a README file, for example, next to the Docker Compose file. But kind of most of the time, it's not even your worry if you're a user. If you're a developer, of course, and you need to understand all the details that are written in that file. But I have been using Docker for like 2-3 years now, and I still don't understand a lot of the details there, and still I can do a lot of interesting things with Docker. So I wanted to say what I think could be a good couple of meetups ahead, so that you also feel free to join or drop. so far we covered like exclusively and very exclusively the use of Docker images that someone else built. So it's a good time to stop if that's enough for you. And if you struggle, feel free to contact us, particularly through, for example, calling help desks, because Docker does take time sometimes due to configuration issues and installation issues to get up and running correctly. So we can work with that together. What I'm explicitly not covering in this series is the building, being an author of images, because that's a huge topic. I think that it could cover too many meetups. And from the last meetup series, I learned that we kind of lose focus and interest as we get too deep into technical details. So I wanted to give you now like an exit point where, okay, in 3 meetups you learn something potentially useful, and then you move on with your life. If you stick around, what I'm going to be covering in the next meetups, maybe 2 more, is mostly the managerial aspect of Docker. So now we run images and they are there. So we have images that have been saved in our systems. How do we get rid of them? For example, if our computers start to blow up, right? Or you're starting containers and they're all kind of running and they're up there somewhere. So how do you actually stop them? How do you restart them? How do you remove them? So that is the management aspect of things that, very soon, if you do use Docker, you will need to know. But if you just need to run Docker once a month or something, then probably with what you've learned until today, you're good to go. And when you see that something is odd, you can just reach out. So the rest of the series, I envision it as being more of the managerial aspect of it, and then wrap up. And then maybe I need to discuss with Alex, because the building images is something that is very interesting to us, but not sure if it's interesting to everyone else. So before we get into that, I would like to kind of have a conversation to see if there is enough interest. If not, that would be a very good point to start another series about the basics of the terminal, because I think that even if you wanted to learn to use more Docker more intensively, you will need to be a little more fluent in the terminal. So covering Docker in full without that knowledge first would be very difficult. So I would prefer to now stop, then start a series about the terminal, and then maybe if there is interest, go back to Docker in more kind of dev-oriented topics. Oof, that was a long one. Sorry for that. Any departing comments before we go?
Nothing from my end.
All right. Thanks, everyone. Sorry for going over. And if we don't see you the rest of this series, have fun with Docker, and we'll see you in the next series. Ciao, ciao.
Thank you.